This video will explore the current divider rule, one of the most used analytical techniques in electrical engineering. The current divider rule states that when current reaches a junction, the current will divide into the parallel branches in the circuit with a ratio proportional to the inverse of the resistance in each branch. Now for an analogy to help us understand the current divider rule. Let's say we have a train where each carriage of the train represents a charge. As we know, current is the amount of charge passing through a point in a given time, so the faster the train is moving, the higher the current. Now let's say the train is reaching a junction, in which the track splits in two. The track to the left has a large tunnel, and the track to the right has a smaller tunnel. As we can see, the tunnel to the left is larger than the train, while the tunnel to the right is much smaller than the train. Since the larger tunnel produces less resistance, it allows more carriages to pass through the tunnel per unit time, a higher current than the smaller tunnel, with greater resistance allowing less carriages to pass through per unit time, a lower current. As we can see, when the current divides, the path with the least resistance will have a greater current than the path with the most resistance, an inverse relationship to the resistance in each branch. The current divider rule finds that the current through branch X is equal to the source current multiplied by the total resistance through all parallel branches divided by the resistance in branch X, as seen in the displayed equation. Special cases of the current divider rule include parallel elements of equal value, where the current will divide equally across all branches, and two parallel resistors, where the current through each branch can be found by multiplying the source current by the resistance of the second branch divided by the sum of the resistances. Now for an example, find the current through each parallel branch of the displayed circuit. Remembering our equation, the first step is to find the total current across the branches, which we can see is 625 ohms. Now let's find the current in I1. We're going to take the source current, 0.0192 amps, and multiply it by the total resistance in the circuit, 625 ohms, and divide that by the branch resistance, 10,000 ohms. As we can see, the current through I1 is 1.2 milliamps. Now let's find I2. Again, we're multiplying the source current, 0.0192 amps, by the total resistance, 625 ohms, and dividing by the branch resistance, this time 2,000 ohms, giving a total current in that branch of 6 milliamps. Finally, I3 can be found using the same process, this time dividing by 1,000 ohms, giving a current of 12 milliamps. As a final step, the answers can be verified by ensuring the sum of the current in the branches is equal to that of the source current. As we can see, the sum of the current in the branches is equal to 0.0192 amps, equal to the source current. Thanks for watching, and I hope you now have a greater understanding of the current divider rule.